Alright, so welcome. Today we're going to go over a little demonstration to sort of analyze a common formula that we use in geometry quite a bit and we've been using throughout the year, but we've never actually analyzed where this formula comes from. And as we go along, you'll hopefully start to see what the formula is, but for right now, know that what I want pair of identical squares. There we go. Let's just kind of put them side by side for right now. Alright, so we'll notice the two squares are the same size. Everything's good to go there. So let's take this first square, mark it off a little bit. So what I want to do is take a mark partway off of the top left corner and partway above the bottom left corner. And let's draw some lines to mark off these regions. So we've basically taken our box and we've split it into two squares and two rectangles. All right, let's do something similar to this triangle here. This time, I'm going to mark it a little bit differently. So the first two I want are going to mark the same way. Then I want to mark the bottom and right side in similar fashion. What I'm going to do is draw some lines to connect to the points that I just made. And if everything was completely straight, we should notice that we just created four right triangles and a square, a slanted square inside the second box. Okay, so let's look at what happens if we take the area of each of these boxes. Or rather, let's start by counting up the number of boxes in each section. So let's see, I've got 2 here, 4 here, 4 here, 2 here, 4, 2, 2. Let me scoot this guy over just a little bit, give me a little bit more room. Alright, so 4, 2, 2. Okay, so next thing we want to look at is the area of each set. Try to make that line up just to make it look a little bit nicer. There we go. Okay. So if I count the number of boxes inside each shape, or rather the area of each shape, I will notice there's 8 boxes here, 16 here, 4, and 8. Over here, I know that the area for a triangle, if I want to do this using a formula, is half the base times the height. So 4 times 2 is 8, divided in half is 4. And since the two squares are exactly the same size, their total area should cover the same number of boxes. And if I'm having a hard time finding the area of that square, I should count the total number of boxes in the blue square, subtract out the 4s that I've already written, and whatever is left over should go on the inside. So if I take my 6 by 6 square, it should be 38 squares on the inside. If I take 36 and subtract out the 16 for the 4 boxes, right? So 4 by 4 would give me 16. I should have 20 left over, so this should be the equivalent of 20 boxes. Okay. Let's look at what we notice about this, this, and this. Well, 4 plus 16 equals 20. If I had changed the size of my squares, I'd still get that same pattern, where the 2 inside squares on the left side equal the inside square on the right side. If you don't believe me, try it on your own. Draw 2 squares marked in the same way. The pattern will always persist. Well, if that's the case, what if instead of using numbers, we had used some variables? Right? So instead of 2 and 4, let's call all the 2's A. Let's call all the 2's B. Or the 4's will be B. So there's A. There's B. There's B. There's A. And let's do the same thing going around. I notice there's one line that I did not label with the letter. And that's the line on the slanted square, the red square inside the second box. I've already used A and B, so why not just keep it going in order? Why not just call these guys C? Because again, this is a square, so they're all the same size. All right. So hopefully this is starting to come together. If I wanted the area of the bottom left square, I did 2 times 2, that gave me 4. So if I want the area in terms of A, I would take A times A, that give me A squared. If I want the area of the upper right box, I did 4 times 4 to get 16. So if it's B instead of 4, B times B is B squared. And while I didn't necessarily multiply the side lengths together in the red square, I do know that for any square, the length times the width is equal to the area. Right? So, if I wanted to know what that area was, it would be C squared. So what we've just done is verified the Pythagorean theorem. That's all I have for today. I will see you guys next time.